So I am starting today in Schoology because I want to show you some things that we learned about and we want to try those out. So I want you to be familiar with them. So in your Algebra Schoology folder, you see a week 9, that's the orange folder. And then you also see this Topic 3 Interactive Student Edition with the blue folder. If you click on that, that will give you the interactive Student Edition book, and we have all 6 of the lessons there. So if you ever wonder, oh gosh, I need to go back and look over that or I need something from it, it will always be there. And we're just kind of trying out to see how's the best way to do this. But don't worry, we're still going to teach what you need to know. So let's go into week 9. And we're going to go to Monday. Now, I put it both places, so we're going to actually go to the interactive book in just a second. And this will change a little the look of it. When you go into it yourself, it'll look a little bit different because I'll have some more information where it says Topic 3, Lesson 1. But I wanted us to look at this interactive reader, and what we're going to do, so click on that because it's going to take a few seconds for it to upload, and this is going to bring in a textbook, and I want to show you how to use this and how to get to the different places so that this is something you can always use. If there's no video, you can use it. So you want to scroll down and hit the next button. Okay, and then this should take you to the same thing, and right now I'm on page 49 in your book. Then if you come up here, okay, you see the finger pointer, you can make it larger so it's just easier. The other thing I want to show you is if you come over here to these 3 dots, 3 lines, you can actually write in the notebook, and you can put any information right here. Like you could write whatever you wanted to here. I can't write, my pen's not allowing me to do that. And hold on one second. So I just learned some new information. Let's say I want to take notes and I want to put number 1, or I want to put a bullet list. And then when I go to type, okay, at least on mine anyway, I start writing and it's going to let me. So I'm going to say functions. My phone, mine won't do it. Let me go back to this one. It was giving me a keyboard for a second. And it's not now. Okay, but you could probably type in there, write your notes in there, whatever you wanted to, and that will stay with this book. It now becomes your interactive book, but you can write your notes right over here. Okay, oh, there we go. So see, I can start writing in here. I could talk about functions. And when I write in here, now yours might be a little different. When I'm done, it would go into that information, and that will always be there for whatever you write in yours. Yours is going to look different because you're going to have different notes. Okay, so this goes through the problem like we've done before. Yours, and we can write our answers right in here. Now, those answers will not save. So if I try to write anything in this box right here, that first box under A, that will not be saved. But if I put anything over here in my notebook, it will stay. Okay, the desk in a study hall are arranged in rows like the horizontal ones. What is a reasonable number of rows for the study hall? What is a reasonable number of desks? So what we're doing is we're looking at all the desks that we have over here, and you have to figure out what could be reasonable. I know you can play with that and come up with it. Okay, so just kind of look at that. You have 10 total. What could be some possibilities for rows and of how you can arrange that room? So what number of rows would be impossible? What could you not have for numbers of rows? What number of desks would be impossible? So number of rows, number of desks, and explain. Now also you'll see down here that you have a little keyboard. So if you want to put anything in there with numbers, if you want to put variables in, that's probably not as important here because you could just type. Also it has some basic symbols of what you could be using, and also it has function symbols. And we won't use those too often, but it would give you exponents right here. That would be an exponent. Let's see what basics gives you. Basics gives you a fraction, which comes in really handy. It also gives you all these different roots, which could be helpful. It does not give you brackets, which we're going to be using. Okay. So, and then what is your answers to part A and B reveal about what your graphs of rows and desks look like? So, for instance, if I have 10 desks, so for A, hopefully you've already answered it. For A, I could have 5 rows of 5 desks and 2 rows. I could have 5 rows and 2 desks in each. I could even do like 4 in one and 6 in the other. Those are possible. What's impossible? Well, I can't have a negative number. Can't have 0 desks because I have students. Okay, so numbers of rows. numbers of desks would be, which would be impossible. Can't have 0 desks because they're not going to sit on the floor. I only have 10, so I can't go above 11. So I'm capped out at 10 desks because that's how many desks I have. So what does it reveal about the graphs of rows to desks look like? Well, if I were talking about desk and rows, I'm not going to make a graph, a line graph. That wouldn't make any sense. But I could make like a chart. I could even make a bar chart, something like that. So there's other graphs I could be making. So what are other representations you could use to display the student information? Select and describe one. Description, explain how the information would be presented. So if you click here, it's going to go in your notebook. Anytime it goes in your notebook, that will be saved. That will be saved. Okay, let's go to the next page. And it says recognize domain and range. And this is where it's going to be really important that you pay attention, because this is how you're going to use the document. And so it talks about domain and range. And did you notice what topic we're on? The lesson is about relations and functions. Well, here's the problem. What do all those things mean? And you might be going, how do I know that? So if you click on solutions right now, it will give you all this information. So the first thing it says is a relation. Okay, I don't know if you can see that, but a relation is a set of ordered pairs. What I would recommend that you do right now is go to the left-hand column of your book and write these definitions in. Relation is a set of ordered pairs. A function is a relation. It is a relation in which each input is assigned to exactly one output. So each input, and we're going to find out in just a second, or you already know, input, notice it says up here, input are your x values, output are your y values. And then the domain of a function is a set of inputs, your x values. So for domain, I would write down, the definition says here, a function, the domain is a set of input, but it's also your x values. The range is the set of output, which is your y values. Okay, and that's what this is talking about down here in this last sentence. So when we talk about relation, it's just a set of any ordered pairs. Function is a specific relation. It's a specific one in which each input is assigned to exactly one output. Now, I will tell you the other way I think of this definition is that I always say, if it says one input to exactly one output, I remember that my inputs, my x values, cannot repeat. And if I were you, I'd write that down. So in that left-hand column on page 50, write down these definitions. Go ahead and pause if you haven't already done that. The other option is you could come over here and you could type it in. So you could say relation. Let's see if it's going to give me a line. Relation is a set of ordered pairs. Okay? And then I can return, and I can talk about a function. So if you are somebody who likes to put everything in one place, a function is a relation, okay, you get the idea, in which each input has exactly one output. I would also put in there that the function, so I would put like a hyphen, no x values, well, that's not a word, no x values can repeat. Okay? And you get the idea. So you can type this in, you can write it in, depending on what your computer does. I'm sure you'll be able to figure that out. You guys are great with technology. Okay? So then if we look at it and say, well, what's a domain? My domain is, and notice they have it written in set notation. Do you see that right here? That's set notation, because I have that bracket thing. You might have to type that in from your keyboard, and that's that upper right hand side. It's usually right after the P. See, right after the P on your keyboard, there's those squiggly brackets. You have to use shift, but then you can type in set notation. Okay, good. Oops, I need to go back for a second. So, see how there's one black dot right there? you want to go to the next black dot because that's where it's going to go to your book. So on page 50 now, you're going to identify the domain and the range. So what you do is you look at this and you're like, well, what's my domain? Well, this is where you would do that bracket. Now, I don't have a bracket, so I'm just going to do a squiggly. And I'm just going to go, for mine, I'm just going to type in 2. I'm going to go squiggly 2, 3, 4, 5, and 6. Okay, let's see if it will enter. Oh, nope. 2, 3, 4. Well, that's fun. Bad handwriting. And ending squiggly. Let's see if it will. Oh, no, it just makes up its own. Okay, but it did give me the brackets now. So I have 2. Okay, so anyway, play with that, see how that works. But here's the important thing. If you're homesick, try to answer the question yourself, and then it's going to tell you the answer. It's going to tell you what the answer is. Here's your domain, here's your range, and it even shows you what it should look like. I've now used both of my dots. You see both of those dots? I've used them. So now I go to next. Analyze reasonable domains and range. So a function can model each situation. What is a reasonable domain and range of each function? Okay, so a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So what would be reasonable? So think about that. What is a reasonable domain? Meaning, what could I have as input values? What could my x values be? Well, I have a 10-gallon pool, and I'm look at this right here, 10 gallons per minute. Okay, go back to 7th grade math for a second. Think of your constant of proportionality. That means that it's gallons per minute. Okay, I'm going to come over here to my notebook and see if I can get this to work for me. So if I have gallons per minute, gallons, I wish I could make this work. So gallons per minute, that would be y over x. So what could my input be? The number of minutes, okay? And what would be a reasonable domain for minutes? Well, are we going to talk about negative minutes? No. Could we talk about a 0 minute? Yeah. So we can start at 0 minutes and go for a long time because it doesn't have a limit on that. So our domain values would be, and could it be a fraction? Sure. It could be a part of a minute. So it could be a decimal, it could be a fraction. So it's going to be all real numbers from 0 and higher. So 0 and all real numbers after 0. Then we look at what can my output be, so that 10,000 gallons. Well, it can start at 0 gallons, and it can be any decimal or fraction, but it has a limit. It's only going to go up to 10,000. So it's going to stop after it gets to that 10,000. But let's see if we're right. Hit solutions. A reasonable domain is from 0 minutes to the time it takes to fill the pool. Okay, a reasonable range is from 0 to 10,000, the capacity of the pool. Now, we didn't even get to this question yet, so we didn't get a chance to think about it. A restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. So what would be a reasonable domain was the number of tables. I could be from 0 on up, number needed, and then a range would be from 0 to 4. Be multiples of 4 because I need 4 for whatever. So since I need multiples of 4, I'd have 0 and 4 and 8. That's what it means by multiples. Okay, now if you're home absent, look at these dots up here. You need to pay attention and go along on those because I'm not going to always have videos. You can just use the interactive book. Is the domain for each situation continuous or discrete? Well, that's just it. We haven't learned about continuous and discrete. So here's some more definitions you're going to want to put in the side over that blue page 50 over on the side. You're going to want to write down what continuous is. It's all real numbers. Continuous means that I can have decimals and fractions, whereas discrete, I can only have whole numbers or integers. Okay, and so what that makes a difference on is if I'm talking about continuous, my continuous graph can be a line. My discrete one has to be just points. And there's a difference. Continuous can have fractions and decimals, and discrete cannot. Okay? So now what they do is they show you this information and they show you a sketch of what your line could be. Remember, this one's continuous because you can have fractions and decimals. Whereas this one, because you're talking about tables and chairs, you can't have a portion of a chair. You can't have a portion of a table. So these have to be dots. So that's an example of what continuous. My domain is continuous. Here, my domain is discrete. Okay? Habits of mind. Let's read through that. How do characteristics of a situation impact the domain of a function that describes it? Well, one of the things is the discrete, the continuous. If I can only have whole objects, like I'm talking about people or objects, they have to be whole objects, okay? But if I can have a fraction or a decimal, like gallons of water or miles per hour, then I can have continuous. So that those things limit what we can do as far as habits of mind. Okay, so then we go to the next page. Nope, go back. I think I missed a dot. Did I miss a dot? I did that dot. Did I do this dot? No. So this one is what's in your book. So you have to go to all those dots up at the top and figure out what's the next thing in order to find out what's going on. So then you would do this problem. And I'll tell you a little trick too. Okay, analyze each situation, identify a reasonable domain and range for each situation, explain. A bowler pays $2.75 per game. Okay, so per game. So if I'm talking about the price, and here's the other thing we want to talk about here, is independent and dependent. So the x value, let's put it right over here. Okay, and I want you to add to this, the x value is the independent, I started typing and now it's not going to let me go back to it, is it? Okay, x value is the independent. That's supposed to be one word right there. So I'm hoping it will come back. Independent. Independent. So nope. Let me try that again. Well, it is really funky. Okay, so x is the independent variable. Okay. So you can plug whatever you want to in for x. That one is not a problem. Whereas the y value is the dependent variable. And what that means is that y depends on x. So x determines what's going to happen because y is dependent on x. Okay? So look at this one right here. If I talk about bowling in a game, the cost is dependent on how many games. So the number of games determines that's going to be your independent variable. Okay? So reasonable for games. How many games could I play? Well, I could start at 0. I could have 0 games and I could go 0 games, so 0. It's not going to let me type in there. I hope it works better for you. We'll find out in class and hope we learned something for you. So my games could go from 0 on up. We probably wouldn't do like 1,000, but it would be a reasonable number of games. But it'd going to be a whole number. So that would have to be a discrete one because you cannot have a portion of a game. So that one would be discrete. Now the money would be continuous, but because one of them is discrete, the whole thing has to be discrete. Your y value, your range values, would have to be multiples of 275. So 0, 275, whatever 275 times 2 is, okay? Type anything in here, and it will give you an answer. So 0, 2, okay, so your domain is 0 and up. Okay, but it has to be whole numbers. Whole numbers and integers. Wow. We'll all be learning lots, won't we? Okay. And then you can check your answer if it will let you put anything in there. Okay, so my computer, because I think as I'm recording and I'm also trying to type on it, it's not accepting what I'm doing. So you get the idea on how this works, the interactive notebook. If you put any answers in here, and yours will work, and click check answer, then it will tell you the information that you need. And we've done all 3 dots, so we would go to next. Okay, so I would like you to keep working on this. If you're absent, you're going to go all the way through all this information and find it out. Try the problem on your own and then see what the solution is. Sometimes you're just going to click on the solution because you're not sure what they're asking. Then click on the solution. It's going to tell you what's going on. Okay? So go through the rest of that lesson. I hope that helps and works for you. If you have questions, you know where to find us. Thank you.